Welcome to the Human Origin Project, where we explore the science of you. To keep up to date, go to our iTunes channel and subscribe, and please leave a review if you enjoyed today's show. Hello and welcome to the show. Today we're going to be talking about a topic that every listener can relate to because we learn this system early in our school years, and it's the calendar system, and the calendar system that we widely use today across the globe and where it came from. You may not know that our calendar system was installed by Pope Gregory the 13th, and it was installed with purpose to fix a previous problem with the Julian calendar. But we're going to go into what calendar systems really measure, and is our current system the most accurate that we could have, and what did ancient cultures use, and where did the principles of our calendar system really come from? Hope you enjoyed today's show. This is a topic that we will be covering a lot in future shows and also articles on the website. One thing that may surprise you is that ancient calendar systems are potentially far more accurate than the ones we use today. Let's jump into the Gregorian Calendar system.
Hey Steve, how you going?
I'm good, Steph. How are you, man?
Yeah, not bad. Just we were talking about how hot it was last time, and it started raining the next day. So yeah, I guess I got my wish. It's cooling down a little bit, which is nice.
Pouring, and what we should probably note too is that this has been recorded very early in the morning. We normally record at night, but this is a bit of an experiment. We always have to try and fit, when to get these in. It's a lot of work to put a show together, but yeah, so if these sound different, it's because it's very, very early here in the morning.
Still waking up. But yeah, today we're going to be talking about the calendar, specifically the Gregorian calendar system that we use today, and just go through a bit of the history of it and why a calendar is important, and how we got to understand time the way we do today.
Yeah, it's a really interesting, scientific part of society that we don't really consider, day-to-day life, but is absolutely fundamental across, everyone on the planet nearly, that we now use. Well, for the most part, there is a calendar system that most people use across the world, and there's a reason for that. And what we've found too is that there is a big evidence line as to what ancient people did with calendars, and potentially misunderstandings with what we use today. But what I found so interesting is that the center of any civilization is their calendar system. There's no more fundamental aspect. If you're living in society, you can walk up to them and ask them the date and time. They can tell you by looking, at their phone or watch, and that is very fundamental. Because if you imagine if that changes, then you become, very chaotic, really, in terms of communication. Imagine trying to book an appointment with someone that works on a different calendar system. That's why it becomes very fundamental to day-to-day life. But you forget how these systems were formed, and that's what we're going to go into today. The Gregorian calendar, which is the calendar system we use today, and how it works and what it, where it came from.
And I think it's something that I've found by looking at all these systems and thinking about the calendar systems differently to, just what day of the week it is and what time it is and that sort of thing. Every ancient culture that you look at throughout history had derived their own form of calendar. I think this, I guess from the Roman times onwards, there is sort of a more global calendar, but before that, it was every culture understood time slightly differently. They were all sort of following the same principles of, observing the motions of the stars in the sky. But the majority were just, we're isolated, but still looking at time in a similar way. But it's, I don't know, the more we've looked at the Gregorian calendar, it seems to be built on very different foundations, I guess.
Yeah, the foundations, they make sense to us now because we've lived in them. But when you kind of go back, and this is why, the Human Origin Project, what we're about is, finding those lines of evidence that tell us about our history. And calendar systems, it actually even just dawned on me when, it was a long time ago when we first started looking at this. The calendar system isn't astronomical, measure. That's all it's doing. So it's actually measuring a motion of an astronomical body. So for instance, our planet around the sun. But there are many other motions as well, and many other calendars looked at this. But let's start with the Gregorian calendar. And it was implemented in 1582 by Pope Gregory the 13th.
Yeah, I think the 13th. So nearly 440 years ago, it was put in, and it took over from the Julian calendar, I think, which was the system put in by the Romans. And the reason it was changed was because the Julian calendar, it would drift slightly every 128 years. There would be an extra day added to the calendar just naturally. There'd be a seasonal drift. So instead of Christmas Day being on the 25th of December, in 128 years' time, it would be on the 126th.
Yeah, it's interesting to think about
the 26th. Sorry.
Yeah, well, I mean, it is confusing. Yeah, but it's interesting to think that the calendar systems are a little bit inaccurate, and the reason being is that when we're measuring astronomical periods, what they call the tropical year, the time that it takes the Earth to rotate the sun, actually doesn't exactly equal 365 days. So it's 365.2422 years, which equates to the tropical year. And this is a period of 5 hours, 48 minutes, 45 seconds, and 138 milliseconds difference to... So a 24-hour day doesn't fit exactly to a 365-year period. So this is a problem because when you're using that time measure, you're going to have drift, and that's what we're going to look at as to why that happens and how it happens. And it's still happening today. There is seasonal drift, and it's simply from potentially misunderstanding of how calendars work. And it was actually back in the French Anglo War, they had a significant drift because of the way they calculated their time. And so it was, I think, when you look at the records, the English record the date as being on the 12th of July, 1627. I think the English were invading France, but the French recorded it as the 22nd of July on 1627. They agreed it was a Thursday, but that shows that the discrepancies between the calendar can have a significant difference. Imagine if you were defending for a war on the 22nd and it actually happened on the 12th. I mean, you're not really going to get the exact date of the war, but
yeah.
it shows how important that can be.
Yeah, I think that they just had the idea of leap years a bit different, and just that little change equated to 10 days over that period, which is such a strange concept. Imagine trying to meet up with a friend on the whatever the date is, and they arriving 10 days later. It's sort of hard to imagine.
I remember leap years being a funny concept. I had a friend that was born in a leap year, and so we used to say, I think we were probably 8 or 9, and we used to say that he was only really 2 or 3 because he only actually had two birthdays. And that always seemed silly to me because whilst he was a bit immature, he was definitely, he was older than me. And so I was always kind of thought that was a strange concept. But the reason is that if you don't have leap years in a Gregorian system, that the seasons do drift, right? So every 4 years, because of that difference between the tropical and the hour calculation, the seasons will drift 1 day.
Yeah, it's a long time if you think about in the span of one lifetime, or even, that's a week every 28 years of change. And
the season will drift. That means that summer would be a week late in 28 years' time. So roughly, within our lifetime, it would be, it happens. And it doesn't seem significant. You might say, oh, that's not significant. But when the purpose of a calendar is to actually calculate time, that's a direct failure of that. So
yeah, that's one job.
Yeah, one job, calendar, do your job.
That they've, I don't know, a lot of, as the calendar was developing and getting to its current state, there was a lot of, they'd add a festival here or a political event there to try and make up for this slow drift, to make the public catch up, or make the population catch up to where the actual date lied. But it's just kind of these these problems that kept occurring, these short little band-aid sort of fixes that didn't really get to the root of the problem of it. So it's still, I mean, we're still using it, and it still drifts slightly, but it's not it's still not a perfect system.
Yeah, well, let's get into the numbers of that, because it's interesting. So it was in 46 BCE that Julius Caesar implemented the Julian calendar, and he also sticks them up. Many of the Roman Caesars just popped a month in after themselves, which is I think it's August, July, and so forth. But what he was trying to do is fix that drift system. So what he did was he added a day to account for the difference between the tropical year and the calendar year. And so he added one day every year, and that actually fixed the system. So it would only drift, instead of drifting one day every 4 years, it would now drift one day every 128 years. And that seems like a fixed rate. It's like, right, we're good now. 128 years can't be that significant. But by the 16th century, that became a problem, that there was 10 days drift by then. Yes, well, that's exactly when the French Anglo War. Well, no, sorry, it wasn't the French Anglo War, but there was issues that came along, and it actually was fixed by Pope Gregory with a more accurate system. So Caesar added a leap year, so the concept of a leap year, which is we still use today, but the Gregorian system is a fix to the Julian system. So they saw that there was this one day drift every 128, and they added some extra rules to make it more accurate.
Yeah, so I think the strange thing about this whole system, the Gregorian system we use, is that it started off with a slightly convoluted, broken system that was then patched up, again, which we're still using today. So the basis of it all, which I find the most, the strangest concept, the basis for our timing system is slightly skew, which it kind of throws everything out. I mean, if you look back into other cultures' calendars from ancient times, it was purely astronomical, and everything was, you were observing the moon and observing the sun and those motions and calculating time based on natural phenomena occurring. And our system has taken that all almost out of account to a degree, and we are just kind of floating in this calendar system that's slightly wrong.
Yeah, I mean, when you look at the history of that, you see that they were just trying to plug up, that first of all, they just put festivals in, but then Caesar's like, right, no, we need to do this properly and add the leap year, so one day every 4 years. But then the Gregorian system, as you say, was just a patch up, and so all it does is adds some fixes to the Julian system, which was not correct in the first place. So it adds, so leap years happen on a multiple of 4 days, but at 100 years they don't.
Sorry, at a multiple of 4 years?
Not multiple of 4 years, it is the one.
Yeah. So if you.
Yeah, it's confusing.
Yeah. It gets so confusing when you just try and work out how to understand leap year. So I think it's every 4 years. If it's a multiple of 4, it's a leap year. But if it's a multiple of 100, it's not a leap year. So the 1800 was a leap year, 1900 was a leap year, but the year 2000 wasn't, because it was a multiple of 400.
Of 100.
Oh, sorry. Okay. So if it's a multiple of 100, it's not a leap year. But if it's a multiple of 400, it becomes a leap year. So 1800 was not a leap year, 1900 was not, but the year 2000 was, because it was a multiple of 400.
Yeah, so you added these extra caveats that made it more accurate. And so now the Gregorian calendar drifts one day every 3,216 years.
Yeah.
So with that extra little, there's caveats, yeah.
So you can sort of see so originally it was every 4 years they added a year, and then because it was still drifting, they added these new lines to the equation, which, you'd think if the equation needs amending, you just start again and make it fresh and work from a new system instead of adding these sort of patches here and there. I guess if the foundation you're building on isn't supported, it's only going to be a certain amount of time till it all falls apart.
Well, I can kind of understand why that happened though, because it wasn't adopted until, large scale until 1752. So you can imagine if you're trying to put your calendar system, because I mean, say you're an expanding civilization, right? It's extremely helpful to you if people, in other sides of the world are operating on your time and calendar system. And so in order to spread that, if you're changing it all the time, that's really not going to be helpful to, which is what was basically happening, wasn't it? And
I can't remember who said it, but there was a quote about calendar systems. It was something like, he who controls the calendar controls the world, or something like that.
Yeah, I can't remember who that was. I'll have to look that up.
Yeah. But yeah, it is, it does make you think. And I guess there's a lot of political and religious reasons behind the calendar system. So you'd be wanting to push different agendas, not just the time and the date and that sort of thing. But the idea of time as we know it, with the day broken up into 24 hours and using minutes and seconds as multiples of 60, that's been around for thousands of years. I think it was first implemented in ancient Sumeria, something like 3000 plus BC.
Yeah, and that's basically the way, like just dividing a circle into certain divisions, isn't it? And then so it becomes a 60-second minute, 60-minute hour, and that's also built in to the calendar system too. And I wonder if and the 24-hour day too, that comes from Sumeria as well.
Yeah. So all the multiples of the timekeeping numbers that we use today originated in Sumeria, and that you can see it on the clock. If you look at a clock we have today, it's still the same idea where we have 12 hours on a circular plane. It was a similar thing that started in Sumeria with a circle, a flat disc divided into 30-degree arcs, measuring the sun that way, measuring time that way.
Yeah, and that exactly. So time became a very linear, flat concept, whereas previously it was seen as very cyclical.
Yeah, I think that's been such an interesting thing looking into the calendars, because we've sort of been researching, the ancient calendar systems from all over the world, and you find again and again that these old systems are so much more, three-dimensional and open and aware of not just our little place on Earth, but what's going on far out into space, and sort of encompassing those natural motions into the natural motions of daily life, and cutting. I think you can see why that would be so important, and I think cutting away from that and using a calendar system that's just for practical reasons, and it changes your mindset when you're thinking two-dimensionally. You're thinking time is flat.
Yeah, when you're looking
linear.
at a flat plane. I mean, a clock is cyclical, I guess, but it does kind of lock us in this idea of it's linear, right? Yeah, there is definitely a shift in thinking that our current calendar system has. And when you look at the history of it, it might just be misconception, right? That we lost the idea of what the calendar is really doing. It's like, geez, these days are inconvenient for us. There was actually two scientists that recommended a new calendar system because they were sick of, for instance, Christmas Day, for instance, falling on different days of the week. And so we were saying before that it's hard to calculate what day it's going to be exactly, in 2 weeks' time on a date, because it all doesn't line up. And then
that's something that I'm really confused about. It's so hard to, if I want to meet up with you in 5 weeks' time, what day of the week is it going to be on Tuesday in 5 weeks' time? I have to sit there with either a calendar or a pen and paper and work it all out. Whereas the old calendar systems that people would use, in places like Egypt and China and the Middle East, and ones that were very observational, it all fit together so nicely that you could talk about days in 5 weeks, you could talk about days in 5 years, and you would know what day it is. Whereas now, I think that's completely like no one knows that. And then that's something that's kind of been interesting for me, realizing that that is something that was important to these ancient timekeeping systems.
Yeah, and the solution proposed by these it's called the Hank Henry Permanent Calendar, where every day would fall on the same day, week of the year. That also is kind of more of an adjustment. It kind of seems like they're fiddling more with the Gregorian in a modern context rather than actually going to the actual principles of what a calendar should be, which is an astronomical measure of time. You know, once you disconnect it from that, the whole purpose of it is changed. And when you look at the Gregorian calendar too, you know, the 12 months, you know, it is an adapted lunisolar calendar. So it's a purely solar calendar because it's we just measure the Earth's rotation around the sun, but the months are supposed to be divided into what was a calculation of the lunar cycle. So the 28 or 29.5 day cycle of the lunar, which many calendars do calculate. And there's actually 13 cycles in a year, isn't there, of the lunar calendar? Yeah.
So a lot of the ancient calendar systems would calculate would be primarily lunar calendars. So they would just, each month would be a lunar month. So you'd observe the moon as it went through its natural cycle, and at the end of that, it would be the start of a new moon. And because the lunar cycle is, I think it's 11 days shorter than the solar year, because each month, and that's another thing with the Gregorian calendar, the length of each month changes. So you've got 30 days here, 31 days there, 30 days here, in not a set pattern. So that adds more confusion to this already kind of convoluted system. But back to the lunar calendar.
There's that knuckle system, isn't there, where it's like,
yeah, it's just, it's, yeah.
But it doesn't make a lot of sense. It's like you got to put your hands together to.
Yeah, but so instead of these ancient cultures adding a leap day, a lot of them would add a leap month, which would just be another lunar month, because as the lunar year would gradually pull away from the solar year, each year would be 11 days shorter. The next year would be 22. When it was just enough, they'd add a whole new lunar month. So it was all in keeping track with the moon cycles, and then understanding that you needed to reconcile those cycles with the solar cycles. And they had these really simple systems to do it. And it just made a lot more sense because there was no fiddling around, and things were occurring in the natural world, and then you would relate that to things happening on Earth. It wasn't the other way around. We didn't sort of fudge dates here and there and decide for ourselves, I guess.
It makes complete sense, and we're going to look at this in more detail, but clearly the moon would have an impact on the Earth's rotation around the sun. You know, it's a sixth of the gravitational force of the Earth. So maybe the reason why lunisolar calendars were so prevalent, and the Hebrew calendar today is still nearly primarily lunar, isn't it?
Yeah, I think so.
And there's a calculation too. If you use the calculations of the lunar cycles and comparing to a purely solar cycle, it's far more accurate as well. We'll cover the lunar calendar. We're going to cover every calendar system because it's important to know every one. But the lunar calendar, and there are many around the world. The Chinese calendar is lunisolar, and that's how you calculate the Chinese New Year. It's by the second new moon after the winter solstice.
Yeah, and there's cultures all over the ancient world that would use these lunar cycles, and because of that, their months would be 28 days long. So in Egypt, Polynesia, across the Middle East, in China, like we said, there's places. Even I think there's a Druid culture in the British Isles that still use that calendar today, which is it's a strange concept, thinking that there are still people using the ancient calendars. It's a kind of a nice thought, thinking that there's still a bit of this history left.
Completely. And when you track it back as well, you know, from Roman to Greek times, they all had many cultures had many different calendars that they would use concurrently. So they measure many different cycles, And so the Greeks, for instance, would use the Sophist cycle, which was based on the rise of Sirius. So they would actually wait until the rise of Sirius before setting the new year. So they wouldn't just have this arbitrary new year date, which the Gregorian calendar and the Romans instituted. They would wait until the astronomical or heliacal rise of Sirius. And they actually, this is the interesting part of this, is that it actually goes back to a tradition in Egypt, and there are other cultures that use and focus on Sirius as well as for the basis of their the starting of the year. And there's potentially a lot of implications for that. But you start to see that, well, from Egypt, they used to say that the rise of Sirius related to the flooding of the Nile, but that hasn't been quite, doesn't quite line up in that way. It relates to it, but not exactly. What they were actually looking at is an astronomical timing point, and they would have this little, basically like leap period where they were waiting to observe the rise before starting the year.
Yeah, were they the intercalary days?
Exactly, intercalary, which is what a leap year is, an intercalation. It's just a fudging.
Just adding a little bit of time in.
Well, actually, but for the Egyptians and the Greeks, there was a purpose for it. The intercalary days had a purpose. They were actually just waiting for the time to sync up so that they wouldn't fall out of period. And if you look at Egyptian history, their calendar system remains vastly accurate over the thousands of years of their history, far longer than our civilization, via these using these multiple calendar systems. And it went to the Greeks, and then it seemed to have got lost for some reason. It's a really interesting line of evidence, where you see how we've become somewhat disconnected and confused with what a calendar system really does.
And a lot of old cultures didn't have just one calendar either. I know that places like Egypt had, I think, 4 or 5. Places like in North Africa, like the Dogon and the Bombara tribes, have the same amount, really similar ones to Egypt. And these would be civic calendars. They'd be measuring the rotation, the orbital period of different planets, obviously the seasonal calendars. So there'd be all these different systems in place just to keep reminding people of all these things. I don't know, there was just an obsession with the skies and the motions of the planets, and they had these really ingenious ways of understanding and notating those.
Yeah, it's fascinating too. And you see these systems all around the world. Like for instance, they use different number sets. It's 13 and 20 and 13 and 28. So there's different ways you can relate these different cycles, and they would find meaning in this. There's many cultures that use that number set, isn't there?
Yeah, so the Gregorian calendar uses a ratio of 12 to 60 for our calendar system, which is 12 hours. It's just a multiple. It's 24 hours over 360 degrees of a circle, I think. I'm not too sure. We're going to go into that, but
there's a lot into that.
Yeah, but a lot of old cultures, instead of using multiples of 12 and 60 for their timekeeping systems, they'd use 13 and 20 or 13 and 28, which relate to all sorts of different things, but primarily to musical scales and the harmonics that naturally form in sound and light and things like that, which is a very fascinating idea and something I don't quite understand yet, but we will definitely get into it.
And it does go into an interesting area with the numbering systems, how what they actually relate to. 13, I think, relates to the lunar cycles of a year, right? So the months, and then the 20 or 28, depending, I think. So the 1320 is very important in the Mayan calendar, and that equates to 260 days, which also equates to the human gestation period, which is pretty crazy. And then you go into the details of the Mayan calendar. There are many
Yeah, I think every time I come to your house, you've got a new book on the Mayan calendar.
I'm obsessed with the Mayan calendar, and we've interviewed a Mayan, a descendant of a Mayan shaman, which was enlightening. And yeah, I'm going to Tulum in May, which is going to be great. But I feel that the Mayans were masters of their calendar system, right? And they were mathematicians. They calculated periods far longer, which is really where this is going. Is there's a lot more you can find out with calendars if you really go into what was happening. The 2012, the whole idea that the world was ending then due to the Mayan calendar, that was just the end of a very, very long cycle. And we're going to go into what that is about. And, it's when you look through the evidence and you really pin through it, it's very lost, but looks like they were measuring an astronomical phenomena, which is just fascinating.
Yeah, it really still blows my mind thinking about these old cultures having the ability to measure distances of time so far away, but also astronomical bodies that weren't discovered in modern times until the 1800s, the 1900s. And there's these ancient cultures talking about the size of these objects, the orbital periods, and there's just all these occurrences of this, and it was so important to them. And just really they were really obsessed with understanding everything that was going on in the sky and in the heavens.
Yeah, they seem to understand that there was a purpose to and a use for recognizing, but that's what when you think about it in its essence, the purpose of the calendar, as we said, is to measure time. So that's what they were doing. So they were just doing it accurately instead of being somewhat lazy like we are. We've lost even trying to explain the calendar system, let alone trying to do it accurately. And it's a lot of work too. It's complicated. When you kind of look at we've only just scraped the surface of the numbering. You see how they made the Gregorian calendar. It is quite complicated, but it gets far, far deeper when you're calculating 9 cycles, the 9 Mayan calendars, and then the larger cycles that all click in together. And the 1328 cycle, which is used in China, Polynesia, the Middle East as well. There's a lot more going on than just the Earth revolving around the sun too. And it also fits into the dynamical universe theory as well. Not theory, the discovery that we are in a moving system, the Milky Way, that has many, many motions, and it seems very kind of limited as well, just to be basing our ideas on our little planet's rotation around the sun, when really there's a hell of a lot going on, and we know that that's astronomically happening now. Yeah,
and we definitely I for one feel a very big disconnect from that, and I've only sort of been noticing it and understanding that there is more going on by looking into the calendar systems and looking into these what these ancient cultures were doing and what they were talking about and what they were measuring. Because where I live in Sydney, you can't see the stars. I mean, you can maybe if you go south or north an hour or two, but you could live your whole life forgetting that you're part of something like all these big, amazing bodies and astronomical phenomenon going on just right above your head. And these old cultures that were living out there, observing it every night, you can see why it was so important to them and how they would want to understand that and relate that to themselves and their cultures and keep a record of it all. And
one thing I've been trying to do is to make to start observing the stars, and just in the process of buying a telescope. And
really,
get a good one. But it's important, right? But something I can do now, I can look into I never knew this, but you can observe the planets, right? And you can see, you can pick them out. You can see Mars, you can see Venus, the morning star, and there were many, references to this in ancient cultures. There's a lot of information there, and they have this very you can calculate their cycles. But I kind of feel that this is moving towards almost a Copernican or Galileo level of understanding, where before we thought the Earth was the center of the universe and everything revolved around us. It took hundreds of years for the idea that we revolve around the sun to really kick into acceptance. But the big thing of that is, is the next stage going to be understanding, what our motions are within, the larger cycles, the other planets, the other stars in our galaxy, the other galaxies, are all of these that, we are learning that in this moving universe, there are many, many motions that would be affecting us. And so it's really interesting, and it brings a lot of different fields of study together, which is what we aim to do here. And also, there's a lot of researchers doing good, using very modern techniques to show that that's the beauty too, is that we have great techniques to kind of measure the stars and understand these things too.
And I think, just touching on that with, thinking about, being part of a bigger motions and larger bodies, and thinking, I don't know, once your mind starts wandering out towards the sun and the moon and the solar system and the galaxy and more galaxies, and you keep going out and out and out, and then you come back and just think back to our calendar system and our Gregorian calendar. It feels very disconnected, and you feel like very isolated from everything else that's going on. And I think that's been the biggest thing for me, having that sort of shift in perspective of you realizing that we are potentially missing out on understanding this whole other side of existence, which is going on out there, and we just don't really talk about it because it's not part of our daily timekeeping system or part of our daily routine or anything. We're completely cut off, I guess.
Completely. And these are distances and real phenomena that we know with reasonable scientific understanding now. So you can picture these things in your head. For instance, say you're on the other side of the Milky Way, and looking back in the sky at our star, which is the sun, which is our tiny little planet, which you might be able to see via Doppler shift on the it's the way we measure planets is via a tiny little fuzz in front of a star. But imagine how silly you would think if people on that planet were thinking they're only measuring their calculation around that sun, how small-minded they would be. And that's potentially the perspective that people are looking at. So I think that pretty much covered the Gregorian calendar, didn't it?
Yeah, I think so. I think it's a good starting point to dive into these other calendar systems, and then it kind of gives you a good insight into their mindsets as well and what they valued. And it's a lot of research, but it's been interesting and exciting.
Yeah, I always look forward to the calendar stuff. It's something I'm really drawn to, but it's just fascinating because it mixes science and history, and there's going to be lots more of this to come. And perhaps we'll be designing a new calendar. We could call it the Rustborn calendar, or something along those lines.
Yeah, I think that would be good. I think it's kind of thinking about, I don't know, it's nice having these conversations and then being able to apply it practically. I mean, you can go out on any night if you can see the stars and just observe the motions. And it wasn't until about a year ago that I realized that if you look at a constellation in the night sky, 2 hours later it's going to have moved, and that it'll return to the same spot every night. But then there's like these slight motions that take upwards of 26,000 years that the ancients would talk about and put in their calendar systems as well. So it's just like it goes deeper and deeper and deeper, and we'll talk about that later. But it's a very it's an exciting topic for sure. Oh yeah, you can go to any level of complexity, which is just mind-boggling. Yeah, and it all matters. Once you zoom out, it goes beyond our planet, but all this stuff is affecting us in the universe. Yeah, well, it's been a good chat. It's very early, so sorry to everyone if we sound a bit strange, but looking forward to sharing the next few installments of the calendar systems and going a bit deeper into this topic. It's been it's really endless and exciting.
Thank you for listening to today's show. For more information, you can read the full transcript, articles, and discussion on our website, humanoriginproject.com. You can visit us on social media at Human Origin Project on Facebook and The Human Origin Project on Instagram. Follow us on Twitter or join the forum boards and email list to keep up to date with all the new information. And if you enjoyed today's show, please subscribe on iTunes and leave a review, because it helps others to find this information and helps us to bring you the topics you want to discuss and hear about. Until next week, I hope your life is filled with happiness, healthiness, and harmony.